The first reaction we will be talking about is a double replacement reaction. A double replacement reaction is when two compounds react and two elements from each compound switch to create two new compounds. This reaction starts off with PbNO32, which is aqueous because it is an ionic compound that appears in liquid form, and 2Ki is aqueous because it is an ionic compound and is liquid form also. This reaction gets you two products. PbI2 is solid because it is an ionic compound in a solid state. 2KNO3 is aqueous because it is an ionic compound in liquid form. This equation, unbalanced, is PbNO32 Ki to get PbI2 plus KNO3. To balance it, you have to count the amounts of every element on each side and make sure that both sides have equal amounts of each element. On the reactant side, which is the left side, there are two nitrogens, but on the product side, there is only one. To balance that, you have to put a coefficient of 2 in front of KNO3 to give you 2 nitrogens, 6 oxygens, and 2 potassiums on the product side. On the reactant side, because you now have 2 potassiums, when you finish, you have to have 2 potassiums to start with. So you put a coefficient of 2 in front of Ki, giving you 2 potassiums and 2 iodines. Now both sides are balanced because the same amount of each element is on each side. Finally, there's a subscript of 2 under iodine and a subscript of 2 under nitrate because you also have to balance the charge of the ions.
The second reaction is decomposition. Decomposition is when you start off with a single reactant or a compound and it gives you two products. The reaction starts off with CuCO3, which is solid because it is an ionic compound in its solid form. The first product, CO2, is a gas because in nature it appears as in a gaseous state. The second product, CuO, is a solid because it is an ionic compound in its solid state. The equation is already balanced because you have an equal amount of each element on both sides. Finally, there's a subscript of 2 under oxygen because you have to balance the charges.
The final reaction is single replacement. Single replacement is when you have a compound and an element, and that singular element switches with an element inside the compound. The reaction starts with 2HCl, which is a liquid because hydrochloric acid appears as a liquid in nature. And the second reactant, 2Mg, is solid because in its elemental form it appears as a solid. The reaction gives you two products. 2MgCl is a solid because it is an ionic compound in its solid form, and the second product, H2, which is a gas because it appears in nature in a gaseous state. The unbalanced equation is HCl plus Mg, which gets you MgCl plus H2. To balance it, you have to add a coefficient of 2 to HCl to give you 2 hydrogens on both sides, but that also gives you 2 chlorides on the reactant side. So you must put a 2 in front of MgCl on the product side, giving you 2 chlorides on both sides. But that also gives you 2 magnesiums on the product side, so you must put a coefficient of 2 in front of Mg. Finally, you put a subscript of 2 underneath hydrogen because hydrogen is a diatomic molecule and appears in nature bonded.